Linux Technologies.
Welcome back to Simac Tutorials, where you learn how to practice your Linux procedures on Simac. This time we will explore beam steering, and how steering magnets are used to precisely control and direct the radiation beam. We use beam steering to ensure our beam profiles are symmetric. It's important to have symmetric beams, to ensure the dose delivered will match the predicted dose in the treatment plan, which assumes a symmetric beam. We steer beams with magnets surrounding the entrance and exit of the waveguide. Let's see how to steer our beams and ensure they are symmetric. Let's go to the Steering tab and see how the magnets are controlled. Here you can see the 6 magnets that are used to steer the beam. These steering magnets, located along the beam path, generate magnetic fields that interact with the moving electrons. According to the Lorentz force law, when a charged particle like an electron moves through a magnetic field, it experiences a force perpendicular to both its velocity and the magnetic field. As the electron beam passes through the magnetic field, it is deflected. By adjusting the strength and orientation of these magnetic fields, we can precisely steer the beam. Their corresponding controls are located in this table on the right. By changing the current flowing in the magnets, it is possible to adjust the magnetic field strength, which affects how the beam is deflected. Below you can see the in-plane and cross-plane dose profiles for a correctly steered beam. Generally, we would use a water tank scan to achieve these graphs. As you can see, the beams are symmetric, and Simac calculates the symmetry value to be 0. Let's see what happens if we have an asymmetric beam that we need to correct. We can introduce asymmetry, using the gun error function, and then correct it with the steering adjustment. Let's introduce a 0.2 mm gun misalignment in the radial direction. As you can see, the in-plane profiles on the left have changed and became asymmetric. The change might be subtle and difficult to notice. We can use the mirror function to mirror both profiles along the central axis, to highlight any asymmetry in the profiles. We can manipulate the positional coil current, to make the profile symmetric again. The in-plane profile is affected by the radial coils. I will introduce -25 mA current in the radial positional coil. Let's run a simulation and see what it gives us. Almost. How about -22 mA? Nice, a perfectly symmetrical profile. Similarly, cross-plane profiles are affected by the transverse coils. Okay, great. We steered our beam and were able to investigate how the different magnets affect the symmetry. If you want to learn more, you can use Simac to practice beam steering. To get started with Simac, create a free account at linux.ca, get free simulator runs every day. Thank you for joining this Simac tutorial. See you at the next one.